Okay, so um, in this video, I'm going to be talking about where the derivative of cotangent comes from. So if you've seen my video on the derivative of tangent, we're going to be using kind of the similar techniques to actually figure out what this is, although it'll be a little bit different. So um, when we're trying to think about what the derivative of cotangent is, let's think about another way we can express cotangent. So um, oh, big C there. So my cotangent of x, this is the same thing as cosine of x over sine of x, right? Uh, Hopefully you learn this kind of in trigonometry when you're going over the unit circle. You can also think of it as like, you know how cotangent is just 1 over tangent, right? So you can also like think of it as you're like turning it over, you're flipping it. Instead of sine over cosine, now it's cosine over sine. So this is kind of my um, other expression of cotangent of x. And hopefully you're familiar with the derivative of sine and cosine. Real quickly, let's just review. I'll write up here to so that we kind of can reference it when we need it. So, oh, the derivative of sine, let's start with sine. Well, this is just equal to cosine, right? Cosine of x. And let's go over the derivative of cosine of x. And that leaves us with negative sine of x. Um, I really recommend you get super duper familiar to the point where it's second nature. You don't even have to think about it. You say, okay, derivative sine, cosine, derivative cosine, negative sine. It gets super helpful, especially when you get into integration, when you start doing opposites and things. It gets really weird, but I recommend you be familiar with this stuff. So, it looks like I have cosine. I'm gonna try and differentiate cosine over sine because we know kind of this stuff. We kind of know how to go about it. So it looks like we have the quotient of two functions. I have cosine of x divided by sine of x. And let's go over a quick review because we can actually use quotient rule to help us out and find out what this is. So real quick, I'm going to write down our definition of quotient rule. And the quotient rule states that if we are trying to take the derivative of f of x over g of x, this is going to be equal to f prime of x times g of x minus f of x times g prime of x, all of this over g of x squared. So this is quotient rule. And it looks like we can just use quotient rule in combination with our knowledge of sine of x, the derivatives of sine of x and cosine of x. So let's actually go ahead and do that. Real quickly, I'm going to move this down a little bit so we have more room. I don't expect that we'll run into problems, but you never know. So, okay, so let's write this down. The derivative of cosine of x over sine of x. Okay, so we're going to take the derivative of the first. So right here, f prime of x. Well, we're thinking of f of x as our cosine, g of x is our sine. So the derivative of cosine is negative sine, right? Negative sine of x times the bottom, which is sine. So this would be negative sine squared of x. And I'm going to subtract cosine of x, because it'll just be f of x times g prime of x, which is sine of x. And then the derivative of sine of x is actually just cosine of x, right? So this will also be cosine squared. Okay, and this is going to be over g of x sine squared of x. Okay, so if you have gone over the proof to derivative tangent, this might give you a little bit of deja vu. It's very similar yet a little bit different. So what I'm going to do is, just to make this a little bit easier for us to recognize, let me factor out a negative 1 out of this top over here. So it leaves us with sine squared of x plus cosine squared of x over sine squared of x. Okay, so we've seen this before, hopefully, right? Sine squared of x plus cosine squared of x. If you've taken some trigonometry classes, you'll hopefully be familiar with the Pythagorean identity, right? So based on the Pythagorean identity, this is just going to be 1. Sine squared of x plus cosine squared of x is equal to 1. That comes out of the Pythagorean theorem and the unit circle and stuff like that. It's pretty cool. So this top is just going to be 1 times negative 1. So this just leaves us with negative 1 over sine squared of x, right? So this is a definition of the derivative of cotangent of x. You might not see it this way. You might end up seeing it as negative cosecant squared of x. and I kind of ran out of space here, but hopefully you can see it well enough. And really, this is our expression for the derivative of cotangent. So I'll quickly write this down so we can evaluate and just kind of appreciate how far we've gone. So we know that this is going to be negative cosecant squared of x. So if you ever, let's say worst case scenario, you're taking the AP Calculus exam, or you're I don't know, taking an important exam for a college class or something, and they want you to know what they ask you the derivative of cotangent. You're like, oh crap, I forgot. Well, if you forget that it's negative cosine squared, you can do this. You start from here. You can do quotient rule, go through all this jibber jabber, and then it'll get you back to where this is. So it's always really helpful to remember. Oh yeah, this comes from quotient rule, and just knowing the derivatives for sine and cosine, and that'll help you out on a test if you forget. Although I do recommend that you usually don't use cotangent. Usually it's more a tangent you want to memorize, but this is still a good one to memorize, and you can kind of memorize it just based off of tangent, because instead of secant, it's cosecant squared. And it's, I mean, instead of secant squared, it's cosecant squared, and it's negative. And you can think of like this is where the negative comes from. It's because I had to factor out that negative one there. So, anyway, we found the derivative of cotangent all by ourselves. We didn't even have to look it up. It was pretty cool. We just needed this founding knowledge and knowledge of the quotient rule. So, anyway, I'm repeating myself a lot, but hopefully I'm not wasting your time. Anyway, I hope you found this video helpful, and I'll see you in the next one.